Tonight you have a video to watch about domain and range, the vertical line test, and function notation. Feel free to pause the video at any time to write down some notes, and then just restart whenever you're ready. Alright, let's start talking about domain and range. The domain and range are words that are used to describe all of the x and y values that are possible. So, if I'm looking at the domain, I'm thinking about what are the possible x values. For this graph, I'm thinking, could x be negative 10? Yeah, because if I go down, eventually this blue line will hit negative 10. Could it be negative 9? Could it be negative 11? This arrow down here indicates that the line will continue on and on and on forever and ever and ever. So that means I will have a point for all of these possible x values. Once I get to the positive side, again, this arrow indicates it's going to go on and on forever and ever. So there will be x values for all of them. So in this case, my domain is all real numbers, because there's no instance of an x number that will not give me a y value. Thinking about the y values, I'm doing the same thing. Start down below. Could it be way down here at negative 10? Eventually, because this line will continue on and on forever, so eventually this line will hit and there will be a y value of negative 10. I could talk about all of these possible y values. Keep going into the positives. The line continues up on and on forever, so there will be all real numbers again. That's not always the case though. So let's look at something that doesn't have all real numbers. Okay, starting with this parabola. The domain, remember the domain is the x values. So I'm thinking to myself, starting down here, what are the possible x values? Will there be a point on the graph for all of these little x values? Since these arrows indicate that the graph is going to go on and on and on forever and ever and ever, it's going to keep going this way, so it will hit all of these negative numbers. Same with over here. The arrow indicates it's going to keep going, so eventually it will get to all of the x values. So the domain will still be all real numbers. What about the range? If I'm starting at the bottom down here, are there y values for any of these numbers? Do they hit the blue graph at all? No. So the y values can't be negative. What's the smallest y value? 0. So the y values, the y numbers, have to be larger than 0. Can it equal 0? Is there a point right here? Yeah, so it can be equal to 0 too. So this is how I'm going to write that y has to be larger than 0. Okay, let's look at another one. So here I'm looking at the domain, the x values. So what's the smallest x value? It's right there at negative 4. Is there an x value at negative 3? Yep, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. 6 is where it stops. It doesn't go any further. So the x values are between negative 4 and 6. Does it include fractions and decimals? Yeah, because here's like 1.5, and here's 2 3/4. So it includes all those decimals and fractions. So we have to use the inequalities to show that we're including those. What about the range? What about the y values? What's the smallest y value? Is it down here at negative 3? Nope. It's right here at negative 2. Oops. So negative 2 is the smallest y value. What's the largest y value? So I'm going looking at negative 1, 0, 1, 2, 3, 4, 5. That's pretty high, but 6 is where it ends. And again, the y values are in between those two. I use an equal to because it includes that point. That point is included. Okay, what about this one? So the domain is the x values. Is there a point on the graph over here? Nope. What's the smallest? 0. So 0 is less than or equal to x. Is there a largest number? No, because the arrow indicates it keeps going. So all I have is that x has to be greater than or equal to 0. What about the range? What about the y values? What's the smallest y value? 0 again. And the y values have to be larger than 0. Since there's that arrow, it's going to keep going. So I know it'll hit a lot of y values. Okay, let's look at this one. This one isn't continuous, right? It's not a connected graph. It's not like a blue line here, or curve. It's just points. So in this case, all I know is that x has to be certain numbers on these points. So let's look at all these points. This is 1, 2, 3, 4, 5, 6, negative 6, negative 1. This is negative 3, 1, 2, 3, 4. This one is 1, 2. This one is 3, 1, 2, 3, 4, 5, 6. This one is 4, 0. And this one down here is negative 1, negative 3. So the domain is the x values. What are the x values? Well, there's a negative 6, a negative 3, a negative 1, 1, 3, and 4. This time we use the brackets because it doesn't include any other numbers. There's no line, so it doesn't include other things. The range is just the y values. So the y values here at negative 3, negative 1, 0, 2, 4, 6. Those are the y values. And that's it. I'm done. Okay, that's the domain and range. The vertical line test is used to determine if a group of points are a relation or a function. Use the vertical line test. If it passes the vertical line test, it's a function. If it fails, it's a relation. The vertical line test means draw a lot of vertical lines. If it hits the graph in more than one spot, it fails. So down here, I'm going to draw a bunch of vertical lines. Each of these vertical lines only hits in one spot. Since it only hits in one spot, that's a pass. So this is a function. Okay, so let's try the next one. Drawing a bunch of vertical lines. If it only hits once, then it passes. So each of these vertical lines hits the graph once. So, passes, which means it is a function. Okay, what about this one? Uh-oh. This one only hit once, but I drew this vertical line and it hit twice. That's an automatic fail, which means it's not a function. That's called a relation. Functions and relations have to do with later when you try to find the inverse of functions. But you'll get to that in intermediate algebra. Okay, what about this one, a horizontal line? If I draw vertical lines, it's only going to hit once. So it passes. Is a function. Okay, this one I can draw vertical lines, and when I draw this vertical line, it hits how many times? An infinite number. That's a big fail. So that means it's a relation. What about oblique lines? What if I had an oblique line? Would that be a function or a relation? It would be a function. Good. Okay, what about this one? Draw a vertical line, 1, 2, automatic fail. I don't even have to draw anymore. That's pretty easy. I think you'll catch on to that quite quickly. Function notation is another semi-difficult topic, but I think it'll be all right. The notation for function is f parentheses x, and you read that f of x. What it means is a function, f, so it has to be a function, it has to pass the vertical line test, that's in terms of x. So f, I'm telling you f based on x. So this would be an example. F of x equals 3x minus 4. You've always seen it as like y equals 3x minus 4. The y and the f of x, they just mean the same thing. The only reason we're using f of x now is because it's a shortcut to writing points. So for example, if I had this function, I want to find f of 3. This is a shortcut to tell you that x equals 3. So instead of writing when x equals 3, what does y equal? The question will strictly look like f of 3 equals question mark. That's telling you that x is 3, and I want you to find y. So you do the exact same thing that you've always done. Substitute 3 in for x, and solve. The difference is the left-hand side here never changes. It stays the same. So this is really giving you, if I made a little xy table, x is 3, y is 5. That would be an ordered pair. That's a point that would go on the graph. Okay, if x equals negative 2, what does y equal? Same thing, you leave the left side alone, so it'll be f of negative 2 equals negative 6 minus 4, f of negative 2 equals negative 10. So that would be another point I could put in my table, negative 2, negative 10. Okay, let's try a different example. Now let's say f of x equals x squared minus 2x plus 1. So for f of 1, I just put 1 in place of x. So I've got 1 squared minus 2 times 1 plus 1. The left-hand side doesn't change. So f of 1 equals 0. So that's an ordered pair. It's 1, 0. F of negative 2 would be negative 2 squared minus 2 times negative 2 plus 1. F of negative 2 equals, negative 2 in parentheses means I'm squaring that whole thing. So negative 2 squared is a positive 4 plus 4 plus 1. So f of negative 2 equals, not 5, 9. So that's an ordered pair, negative 2, 9. You're not changing the left-hand side, it stays the same. F isn't the only letter that you can use. You can use any variable. G, H, and F are the most common variables used. I'm not sure why, they just are. So I could give you 3 functions at a time and have you evaluate them. So if I said G of negative 3, I would use the G function here because it's telling me G. Put in negative 3. So I'm putting in negative 3 squared minus 3 times negative 3. Notice that I've always used parentheses. You've got to use parentheses so that you've got the right positive or negative. So G of negative 3 equals 18. And then I've got H of 2. So I need to use the H function down here. This is telling me negative 2 squared. Pay attention to where I put the parentheses. They only go around the x. X is right here. So it's just that x. So H of 2 equals negative 4 plus 1. So h of 2 equals negative 3.